awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Assalamualaikum and hi everyone. Welcome back to my channel. Jika anda pertama kali hadir ke channel ini, selamat datang saya ucapkan. Tapi jika anda pernah hadir dan kembali semula, terima kasih kerana sudi kembali. Jadi pada video kali ini kita ada 4 soalan lagi untuk kita bincangkan berkaitan dengan chapter 3 under subtopik Conservation of Momentum yang melibatkan soalan berkaitan 1D collision dan juga 2D collision. So, apa tunggu lagi? Jom kita mula. Alright, we start with example number 1, where this example involve one-dimension collision. Okay, so let's read the question. We have 150 gram marble P. Alright, so I think I want to sketch marble P here. Okay, and then marble P move with a speed of 8 meter per second, collides heads-on with a 120 gram marble Q. Okay, so we have marble Q, where marble Q move with the speed of 5 meter per second in the opposite direction. Okay, so we have another one here. Okay, so let's label first that this is P and this is Q. Okay, the mass of P is 0.15 kg. Make sure you change to kg, and Q is 0.12 kg. Alright, and initial speed of P, so we write UP equal to 8 meter per second. So saya ambil P to the right and Q is opposite direction to the left. Kalau awak nak terbalik Q to the right and then P to the left pun tak ada masalah. Make sure masa calculation positif negatif saja perlu betul. Okay, so since UQ will move to the left, okay, so let's draw the arrow. Alright, so UQ should be negative 5 meter per second. Okay, and then after collision, marble P move in the same direction. So what happened after collision? Alright, so the question state that marble P still move in the same direction. Alright, so this is P. Okay, and Q, how about Q? So let's sketch first. So we have, so after collision, so P still move to the right, and the speed of P is Vp equal to 2 meter per second. Okay, and Q, kita tak tahu Q, so kita akan ada VQ. Okay, so now this is before collision and this is after collision. By using conservation of momentum, we can write that total momentum initial equal to total momentum final. Okay, so this is the starting. Since this is one dimension collision, no need to separate X component and Y component. Okay, hanya satu saja. Kita ada one dimension means that objek ini bergerak in X component only. Alright, so now total momentum initial. So we have two objects, P and Q. So momentum for P, which is MP UP, plus initial momentum for Q, MQ UQ, and it's equal to, so final momentum, make sure mass darabkan dengan final velocity for P, VP, plus MQ VQ. Okay, so VQ ini yang kita nak cari, kita tak tahu berapa. Okay, so now we can straightly substitute. So ini saya rasa tak ada masalah. Okay, so the mass is 0.15, sorry. So 0.15 and UP is 8 plus mass of Q is 0.12 and UQ is moving to the left, so negative, jangan lupa. Alright, so this one 0.15, VP is 2 meter per second to the right, so positive, plus MQ is 0.12 VQ. Okay, so now we can calculate what is the value for VQ. So now VQ is equal to 2.5 meter per second. Alright, so since the value of VQ is positive, so means that the direction is to the right. Kalau berdasarkan gambar rajah kita ni, to the right lah. Sebab kita ambil right is positive, left is negative. Atau kita boleh tulis same direction. Okay, same direction as marble P. Okay. And then B, determine whether the collision is elastic or inelastic. Okay, so we finish A and we want to find B. We want to determine whether the collision is elastic or inelastic. Jadi kita kena ingat bila collision itu elastic. Okay, so bila elastic, so total kinetic energy initial kita kena kira mesti sama nilai dia dengan total kinetic energy final. Okay, but if the collision is inelastic, total kinetic energy initial is not equal to the total kinetic energy final. Okay, alright. So now let's try to calculate first. What is the total kinetic energy initial? So I think I want to use another color. Okay. So total kinetic, okay, so total kinetic energy initial is equal to kinetic energy initial for marble P plus kinetic energy initial for marble Q. Okay, so equation for kinetic energy is half mv squared. So ini adalah initial kinetic energy, so kita akan guna yang ni letak P, bukan A, mp up squared plus half mq uq squared. Okay, squared ni saya highlight sebab ramai yang tertinggal. Okay, jangan tertinggal. Okay, so now let's substitute all the values. So we have 1 over 2 mp, we already know. So just substitute 8 squared plus half 0.12 and this one negative 5 squared. Okay, therefore the total kinetic energy initial you akan dapat 6.3 joule. Kira takut saya tersalah kira. Okay, and then for total kinetic energy final, so I think I want to use red color. Okay, kita buat kat sebelah ni. Total kinetic energy final should be kinetic energy final for P plus kinetic energy final for Q. Okay, sama juga half mp vp squared. This time we have vp because final velocity plus half mq vq squared. Okay, so masukkan semua nilai. So vp is 2, jangan lupa squared, and mq, the mass of q is 0.12, vq kita dah dapat tadi, kita dah kira 2.5. Okay, tak muat. Okay, so now total kinetic energy final saya kira saya dapat 0.68 joule. Okay, so kalau kita comparekan kedua-dua ini, kita boleh nampak that total kinetic energy, so kita sambung dekat atas ni kan. Okay, since total kinetic energy initial is not the same as the total kinetic energy final, therefore, okay, this is inelastic collision. Okay, boleh Alright. So finish example number 1. So let's look at example number 2. Alright, now example number 2, here we have 2D collision. Okay. Nampak gambar rajah tu, kita ada angle, so kita ada X and Y component. So means that this is 2D collision. So here we have 200 gram tennis ball. So the purple color is the tennis ball moving with a speed of 15 meter per second, collides with a stationary ball. Yang color biru tu, okay, 800 gram. So let's highlight. So M2 is stationary. Okay, so the tennis ball is scattered at angle of 45 degree. So this is the tennis ball yang color purple tadi kan. So 45 degree, purple ke pink tu. Okay, purple nak ke pink kan. Okay. And the speed is given for the tennis ball. V1 is 5 meter per second. Okay. Find the final velocity, magnitude and direction. Bila soalan tanya pasal final velocity, kalau dia tak sebut magnitude and direction pun, mesti cari magnitude dan mention what is the direction. Okay, so kita nak cari V2 sekarang ni. We want to find what is V2 and we want to find the angle of theta 2 because the direction is based on the angle of theta 2. Okay, so now so since this is 2D collision, so kita kena buat satu-satu, X component dan Y component. Okay, so we start with X component first. Okay, so X component, so we write that total momentum initial X equal to total momentum final X. Kita buat X je dulu. Okay, so saya highlight dekat sini. Okay, ni cerita pasal X. Okay, and then kita boleh tulis, since we have two masses M1 and M2, so kita nak ada momentum initial for mass 1 in X component plus momentum initial mass 2 in X component equal to P final 1x plus P final 2x. Okay, so since initially objek M2 tidak bergerak, so dia takkan ada momentum. Ingat ya, momentum hanya untuk objek yang ada mass dan bergerak. P is equal to mv. So since before collision, mass 2 is not moving, so no momentum for M2. So saya terus saja potong kosong kat situ. Okay, so now let's expand the equation. Momentum adalah M. So we talk about mass 1, M1, U1x. Okay, plus 0. So tak payah tulis lah. Equal to M1 V1x plus M2 V2x. So sekarang kat sini kita ada V1x. Okay, so since V1 kita tahu nilai dia 5 meter per second at angle of 45 degree, so kita boleh resolve V1. Okay, saya resolve dekat bawah ni ya. So kita ada V1 equal to 5 meter per second. So I want to resolve into V1x. So this is 45 degree. So V1x should be 5 cos 45. So bila awak kira, you akan dapat 3.54 meter per second. Okay, while V1y, okay, equal to V1, saya terus gantilah, V1 is 5 meter per second. So dah akan jadi 5 sin 45. Tekan calculator, V1y also 3.54. Okay, V1y positif sebab dia upward. V1x positif sebab dia to the right. Okay, so kita dah boleh nanti masuk dekat sini. Cuma kita tak ada nilai V2x. Okay, V2x kita tak ada lagi. Tak apa, kita biarkan saja. And then kita substitute M1 equal to 200 gram. Make sure you change to kg. So 0.2 kg U1x. So since mass 1 is moving to the right, so memang dia in X component lah kan. So 15 equal to M1 0.2. V1x kita dah kira tadi 3.54 plus M2, soalan bagi 800 gram. Make sure you change to kg. And this is V2x. So now from here we can find already V2x. So V2x is equal to 2.87 meter per second. Jangan salah tekan calculator. Okay, so nilai V2x kita ni positif. So maknanya direction V2x kita to the right. So kalau kita sketch, maknanya V2x kita macam ini. So betul tak V2x kita to the right? Betul lah. Okay, kalau kita resolve, kita akan dapat V2x dan V2y. Okay, so here is V2x and this is V2y. So now let's move to the y component. Okay, so we have total momentum initial y equal to total momentum final in y component. Alright, so saya ambil kali hijau. Okay, so what happen now? Sama juga macam tadi, kita tengok in y component, kedua-dua objek initially tidak bergerak in y component. kan. Initially both object are moving in X component. Okay, so dia bergerak dekat sini sahaja. Okay, so tak ada. So saya tulis kosong. Okay, so kosong kat situ. And it's equal to, after collision, so kita akan ada M1 final velocity untuk mass 1 in Y component plus M2 pun ada final velocity of mass 2 in Y component. Okay, so we can substitute all the values. So kita dapat M1 0.2 tadi, V1Y kita dah kira 3.54 plus M2 again 0.8 and V2Y. Okay, so from here you can see here we have unknown V2Y dan kita boleh selesaikan. Therefore V2Y is equal to negative 0.88 meter per second. Okay, so negative means that V2Y the direction is downward. So betul lah, V2Y downward. And then the resultant of V2 di sini. Ini yang soalan suruh kita cari, V2. Okay, so in order to find the resultant velocity of mass 2, so V2 is equal to, ingat lagi tak formula ni? So V2x squared plus V2y squared. So substitute nilai V2x yang kita dah dapat tadi dan V2y yang kita dah dapat tadi. So the answer should be 3 meter per second. Okay, so ini jawapan untuk magnitude of the final velocity for ball 2. And then the direction, remember the angle. So tangent, inverse tangent, V2y over V2x. Please substitute the values. So you akan dapat, so ini saya akan ambil modulus. And then the answer for the angle equal to 17.05 degree, which is below positive x-axis. Okay, kalau kita tengok dalam gambar tu pun dia memang below positive x-axis kan. Sini tadi. Okay, the angle here 17.05 degree. Okay, so finish example number 2. Alright, now example number 3. Here we have ball A and ball B. And given that mass of A is equal to 2 kg and mass of B is 1 kg. Okay, A is moving to the right, so it's 4 meter per second. But for B, it's moving opposite direction. Tapi kita tak tahu berapa initial velocity untuk B. So after the collision, what happened? Ball A move at 30 degree from the horizontal. So dah lukis kat sini. And the velocity of ball A tak tahu juga. So VA and VB is moving at angle of 15 degree. But VB kita ada nilai, which is VB is 5.28 meter per second. Okay. So sekarang assume the collision is elastic. So calculate the initial velocity of ball B. So we want to find what is UB. Okay. So this is 2D collision. So make sure you do the calculation of X and Y components separately. Okay. So total momentum initial X equal to total momentum final X. So I will start the calculation with X component as usual. Okay. So now initially both object A and B are moving in X component. So kita akan ada MA UA plus MB UB equal to, and after collision look at here, so we have VAX, we can resolve. Okay, VA resolve to X component, so kita akan ada VA cos 30 degree. VA kita tak tahu nilai dia berapa. And then VY upward, so positive VA sin 30 degree. So kita boleh kira lah kot. Cos 30 degree tu tekan calculator, you akan dapat berapa? 0.866. Check And VY, okay, ini VAX, ini adalah VAY. Okay, so you akan dapat 0.5 VA. Okay, so another one VB. So VB kita ada kat bawah ni, VBY negative, okay, 5.28 sin 15 degree. So negatif jangan lupa ya. So negative 1.37. And VBX pun jangan lupa. Tak muat kat sini. Saya tulis kat atas ni So VBX equal to 5.28 cos 15 degree. So VBX you akan dapat nilainya, cuba kira, dapat tak 5.1? Okay, 5.1 meter per second. Okay, so now back to the equation for conservation of momentum. Okay, so final momentum in X component kita ada MA VAX. Saya suka tulis yang kecil ini. So saya tahu ini merujuk kepada X component. Okay, plus MB VBX. Same goes to this one. Okay, so now we can substitute all the values yang kita dah ada. So MA is equal to 2 kg, UA is given 4, plus MB is 1 kg, UB tak tahu berapa, MA is 2, VAX we already calculate here tapi macam tak lengkap lagi, so kita tulis saja 0.866 VA. Okay, plus VB 1 kg and VBX is 5.1. Kita dah kira dah tadi dekat sini 5.1. Okay, so therefore from here we can write that UB, okay, so this is UBX. Okay, so UBX tu UB lah. So kita akan dapat 1.732 VA minus 2.9. So since here we have two unknown UB dan VA, kita tak boleh pun selesaikan. So we need to let this as equation number 1. So what we want to do next? So we need to proceed to the second equation, where the second equation is come from total momentum, okay, initial in Y component equal to total momentum final in Y component. Okay, so this one is Y component. Alright. So now initially mass A and mass B are not moving in Y component. Okay, sebelum pelanggaran kedua-duanya hanya bergerak in X component only. Boleh. So initially dia akan automatic, saya akan tulis kosong. Okay, tak ada in Y component. But after collision, final momentum kita boleh kira lah. So in Y component ada, sebab kita ada VAY dan juga VBY. So saya akan letak MA VAY plus MB VBY. So let's substitute all the values. So mass of A and VAY kita dah kira tadi 0.5 VA plus MB is 1 kg, VBY kita dah kira negatif. Negatif jangan tertinggal ya. Okay, so negatif. So now from here, okay, look at here, we just have one unknown here, VA. So means that we can finally find VA first. So the answer is 1.37. Tapi soalan bukan suruh cari VA. Soalan minta kita cari initial velocity of ball B, UB. Therefore, okay, we substitute equation 2 into equation 1. Alright, so UB is equal to 1.732. Okay, so let's substitute the value of VA, which is 1.37 minus 2.9. Okay, so UB, you akan dapat negative 0.53 meter per second. Okay, so look at here that the answer is negative sign since the direction of ball B is to the left. Okay, so kita pun dah dapat jawapan what is the initial velocity of ball B. Okay, untuk ini kita boleh bagi direction dia to the left, atau kita boleh cakap okay, to the left, atau kita boleh kata the direction of the velocity UB is opposite direction with ball A. Okay, so finish example number 3. Okay, now let's discuss the last example for this video. So we have 1500 kg car traveling at 90 km per hour to the east. So it's given that the blue color here is 1500 kg car. So we put as M1. Okay. And U1, so given that U1 is in 90 km per hour, so make sure you change to meter per second. Okay. And then for M2, so here we have M2 and U2, so I will write U2 60 km per hour. Okay, so before we start, I want to change first the initial velocity U1 into meter per second. So remember how to change the unit, kilometer per hour. Okay, you boleh buat satu-satu. Kalau you rasa takut silap, boleh buat satu-satu. Okay, kilometer ke atas, kilometer kat bawah. 1 kilometer is equal to 10 power of 3 meter ataupun 1000 meter. Okay, so kilometer kita boleh cancel. Hour dekat bawah, so another unit hour dekat atas. 1 hour, 3600 seconds. So cancel hour. So now you can see here that the unit is in meter per second. So we can write that U1 is equal to 25 meter per second. Okay, practice here bagaimana nak tukar ni. And then U2 initially, okay, mass 2 or car 2 is moving in vertical component. Okay, dia bergerak ke atas, upward. And the initial velocity is 60 km per hour. Okay, so let's change kilometer. Okay, so we can cancel. And now we can calculate in meter per second. Okay, so the answer is 16.67 meter per second. Okay. So now let's start. So since this is 2D collision, so make sure you calculate separately for X and Y component. Sama macam tadi, saya akan tulis macam inilah. So this one should be final. Okay. So highlight sikit. So this is in X component. Okay, now kita cerita pasal before collision. So this is before collision, initial. And belah sini adalah after collision. So before collision, hanya car 1 sahaja yang bergerak in X component. Yang colour biru ni. Okay, boleh Jadi macam mana pula dengan car yang berwarna merah ini? So the second car is moving in Y component. Dia bergerak in Y component. Bergerak ke atas, to the north. Kan soalan dia kata. So, bila kita tulis initial momentum, okay, initial momentum in X component, okay, initial momentum in X component for contohlah car 1 plus initial momentum for car 2 equal to momentum final, okay, in X component car 1 plus momentum final in X component car 2. So kita dah tahu dah before collision car 2 tidak bergerak in X component. So kosong terus. Boleh? Okay. So based on this diagram, okay, saya boleh resolvekan dulu V final into X and Y component. So this is V final X and this is VY. Okay? Okay, so kita highlight sikit VY and this is V final X. Okay. So now let's substitute all the values. So we have M1 U1, okay, M1 U1, okay, in X component equal to M1 V, okay, Vx. Okay, kenapa Vx sahaja? Saya tak letak V1x sebab after collision, okay, car 1 and car 2 are moving together. Okay, they are stick together. Okay, so dia akan jadi Vx saja. Saya tak namakan V1x ataupun V2x. So dia akan jadi Vx sahaja. Okay, so kalau kita susun, so dia akan jadi M1 plus M2 Vx. Okay, so ini adalah M1 plus M2. Sebab mereka dah bergerak sekali. Okay, so M1 is 1500, U1x is 25 meter per second. So kita tambahkan, okay, the mass 1000 for M2 and Vx. Okay, Therefore, we can calculate Vx equal to 15 meter per second. Okay, kita baru cari Vx. Kita nak cari V. Ingat ya, nak cari V. So, velocity after collision. So, V kita nak cari, kita mesti kena ada Vx squared. Kita dah ada Vx plus Vy squared. So, sekarang kita nak cari Vy pula. Okay. So, now Vy, so total momentum initial in Y component equal to total momentum, okay, final in Y component. Okay. So, ini adalah momentum in Y component. Kita asingkan. So, we can write equation. So, saya akan mulalah. So, before the collision, K1 yang color biru itu tidak bergerak in Y component. So, dia akan kosong terus. Plus, K2 is moving upward, okay, to the north. So, dia ada U2Y. Okay. So, kita boleh letak M2 U2Y equal to, after collision, they are moving together, right? So, Vy. So, therefore, we can write Vy is equal to M1 plus M2. Okay, we substitute all the values. Okay, and then over M2 is 1000 times U2Y. U2Y is given, so kita dah kira 16.67 meter per second. Therefore, Vy is equal to 6.67 meter per second. Okay, so finally we can find V. Alright, so saya buat kat tepi ni. So, V is equal to square root Vx 15 squared plus 6.67 squared. Okay, so V, the magnitude of the final velocity for both car after collision is 16.42 meter per second. And what is the direction? Cari velocity, make sure you calculate the angle. So, the direction is equal to Vy over Vx, okay, and theta is equal to 23.97 degree, and this is above positive x-axis. Okay, so kita dah jawab. Okay, so finish all the examples for this video. So insyaAllah kita akan jumpa lagi dalam video seterusnya, which is on chapter 4. Okay, awak doakan supaya saya boleh sambung video-video ini ke chapter yang seterusnya. Semoga anda semua support, share, like and subscribe this channel. Terima kasih, jumpa lagi. Assalamualaikum dan selamat sejahtera.